If you try to upload a petabyte of corporate data to the cloud over a standard internet connection, it won't take days, it won't take weeks, it will take decades. You start the upload, the progress bar crawls forward, and then the estimate updates to something insane, like 42 years. At that point, you're not dealing with a cloud problem anymore. You're dealing with physics. Today, we're looking at how AWS solves this problem using something very uncloud-like, the AWS Snow family. So what exactly is the AWS Snow family? It's a set of highly secure physical storage devices that AWS literally ships to your office so you can move huge amounts of data without relying on the internet at all. There are three main options, and the easiest way to remember them is by size. First is Snowcone. It's about the size of a tissue box, it holds 8 terabytes of data, and it's designed for small, remote, or harsh environments. Think research ships, factories, or field locations where internet access is unreliable or painfully slow. Next is Snowball Edge. This one looks like a rugged metal-plated suitcase. It's built to survive shipping and rough handling, and it holds around 80 terabytes of data. This is the workhorse of the Snow family, and the one you'll see most often in real-world migrations and AWS exam questions. Finally, there's Snowmobile. This is not a metaphor. It's a literal 45-foot semi-truck that pulls up to your data center. One snowmobile can carry up to 100 petabytes of data in a single trip. This is what you use when an entire data center needs to move, and the word massive stops being useful. Now, why does any of this exist? Why are modern tech companies mailing hard drives in the age of fiber optics and cloud computing? The answer is simple math. Your internet connection is like a dripping faucet. Even a good corporate connection can only push so much data per second. A physical device, on the other hand, is like a fire hose. When you copy data over a local network onto a Snow device, you're moving data orders of magnitude faster than the internet allows. It's also dramatically cheaper than upgrading your entire network just to handle a one-time migration. Here's an exam tip worth memorizing. If an AWS certification question mentions moving petabytes of data or talks about limited or unreliable internet connectivity, the correct answer is a Snow family device. And if the question starts talking about truly enormous scale, like exabytes, that's your cue for the Snowmobile truck. So how does this work in practice? The workflow is intentionally boring, and that's a good thing. First, you log into the AWS Management Console and order the device you need, just like requesting any other AWS resource. Next, AWS ships the device to you using standard delivery. When it arrives, you plug it directly into your local servers or network and copy your data over at local network speeds. No internet bottleneck, no waiting years. Once the device is full, something clever happens. The e-ink shipping label on the device automatically updates with the return address. You hand it back to the delivery driver, and AWS takes it from there. When the device reaches AWS, they connect it directly into their infrastructure and ingest the data straight into Amazon S3. Your data never touches the public internet during this process, and it stays encrypted the entire time. At that point, your massive data set is finally in the cloud, safely and efficiently. But a new problem immediately appears. What happens when millions of users try to read that data at the same time and your database starts falling over? Click the next video on the screen to learn how AWS solves that problem using Amazon ElastiCache, and I'll see you there.